Hello, my name is Rebecca. I'm a student ID HCT142910. Today, my topic is about how the data science impact on software engineering. Well, data science significantly impacts software development by enabling developers to make the data-driven decisions, enhancing user experience, improving system performance, predicting potential issues, and creating more personalized and intelligent applications through the analysis of user behavior and market trends, all based on large data sets collected and analyzed using the machine learning algorithms. There are some key ways data science influences softwares like user experience optimization software, which analyze the user data to understand the patterns and preferences. Other one is predictive maintenance, fraud reduction, personalized recommendation, which like users using the data to generate a personalized recommendation for products, services, and the content based on individual interests. Targeted marketing campaigns is another kind of software which will like identify ideal customer segments through data analysis to optimize the market strategies and improve the campaign effectiveness. Performance optimization is another software which monitoring system performance metrics to identify the bottlenecks and optimize the resource allocated for better efficiency. Another is risk management and the natural language proficiency, processing MLP. How data science is integrated into software development. While data collection, gathering the irrelevant data from the various resources like user interactions, systems logos, and external database can be considered as a integrated software development. Data cleaning and preparation is a part, exploratory data analysis, which is called EDA, machine learning model development, and at the last model deployment, which integrating machine learning model into software applications.
My name is Armin, and I will be talking about the literature review as well as the methodologies used for the research. Data science in software engineering has quite a few successful projects, such as the usage in Facebook, Netflix, Google, Uber, and Airbnb. However, it can also be a failure if not planned properly, such as an example that was found from the Pontifical Catholic University of Rio de Janeiro in Brazil. The upside of using data science in software engineering is that in agile development, it can improve efficiency, productivity, and success of software development projects. In planning, it can help set realistic milestones and expectations by analyzing historical team velocity, user story completion rates, as well as estimation accuracy. In development, it can give insight of real-time visibility of the status of development tasks, facilitate early intervention, ensuring timely delivery, and identifying bottlenecks or issues by analyzing test results, bug reports, and code commits. In automations, bugs can be prioritized based on the severity of them, allowing the focus on software quality, stability, and high-priority issues to be resolved. There's quite a few upsides of using data science in software engineering, but it will take a while to talk about all of them. There are, however, downsides of using data science in software engineering if it is not planned properly, such as a project involving the Pontifical University of Rio de Janeiro in Brazil, where they focused on building a machine learning enabled system. I think these problems happened due to a lack of planning, and the problems were communication problems. Due to teams having very different roles, the teams did not communicate well, thus leading to a huge pool of problems. Mismatched requirements when developing ML models. Data scientists did not provide the way that they would like to store the artifacts, leading to large files being opened unnecessarily each time a new model was generated. No proper documentation. The start of the system had well documentation. As the system had changes made to it, the documentation started to fall off, meaning the testers or data scientists had a hard time navigating the system. The research methodology used was a quantitative methodology, as we had used a study within the literature review and quite a bit of statistical data used within the findings part of this project. The article from Christian Kastner named Data Science and Software Engineering Process Models, as well as the article from Utkarsh Sahu named The Data Science and Software Engineering Pipeline, goes into good detail and good explanation of what each role of a data scientist and a software engineering does, and as well as how they can be overlapped. The article from Julian Wallace named Unveiling the Power of Data Science in Software Development goes into the advantages of using data science in software development, as well as how companies already integrate this into their projects. The article from Gabriel Busquim et al. From the Pontifical Catholic University of Rio de Janeiro in Brazil, named on the interaction between software engineers and data scientists when building machine learning enabled systems, shows the difficulties between the data science and the software engineering and the problems they face when working together.
My name is Vichura and I'll be presenting the evaluation and conclusion. Based on our group's research, we explored areas such as AI-enhanced testing and bug detection, AI's role in productivity, and challenges. From these areas, we found that data science has an impact on improving the efficiency in software production, boosting productivity. It also helps identify the errors early in the software using AI tools. Compared to manual testing, this reduces time, increases accuracy, and lowers the cost. AI has shown it can accelerate development, however there are still gaps, particularly with bias and security. These issues need to be addressed to avoid making software quality and reliability worse. We found that by integrating predictive analytics and anomaly detection, data science has improved DevOps. These methods can help identify and resolve issues early. Moreover, methods like automated testing and CI/CD optimization can improve workflow efficiency. While they bring benefits, there are limitations. The quality of data is essential, otherwise data that is poor will lead to inaccurate predictions. Advanced tools are required for implementation. This can be time-consuming and the cost is expensive. Addressing the cost and efficiency is crucial and this requires careful planning. Planning ahead will help optimize resources and lead to successful implementation. AI data models need to be diverse and representative. To ensure this, regular testing AI systems for fairness is essential, as well as adding strong security measures to protect them and to avoid cyber attacks. Research has shown that while data science enhances software engineering in many ways, there are still areas that require improvement, particularly challenges in collaboration, data management, and documentation. Software engineers and data scientists lack the communication. This can be due to different skill sets, priorities, and poor project management. This can cause misunderstandings about requirements and timelines. It can also delay in projects and lead to software that doesn't exactly meet the expectations. They can improve this by having regular meetings and setting clear responsibilities so that deadlines are met and using tools like GitHub to make it easier to track progress. Another issue that can arise is unclear guidelines for storing machine learning model artifacts. For example, reopening large files unnecessarily, which can slow down the development. Also, when the documentation isn't clear, it can make it hard for testers and data scientists to navigate the system. This can delay updates and troubleshooting. To fix this, teams should have clear guidelines for storing machine learning artifacts and keep the documentation up to date and easier to access. It is important to make improvements to this as it helps maintain the efficiency and reduces delays. In conclusion, the future of data science and software engineering is promising. Developments like automated code generation are advancing rapidly, with tools such as GitHub and ChatGPT already improving bug detection, boosting productivity, and reducing human error. Another key development is improved maintenance, where the developers can predict potential system failures earlier and address them before they become serious. For the future, addressing challenges such as data quality and the integration of more advanced machine learning models will be critical. As data science continues to evolve, it has the potential to significantly enhance software development processes, making them more efficient and reliable to future needs. Thank you for listening.